I think what we're going to do is we're going to get started with the maths, and we are going to get started with a little bit of a recap of the last lesson. And in the last lesson, the main topic was something called a cyclic quadrilateral. And so I want to just go down memory lane a little bit to refresh our brains. Actually, probably an image is a good way to review this. So let's see if I can do that. If I go like this. This is a applet from a thing called GeoGebra, and it shows us what a cyclic quadrilateral is. So a cyclic quad has all four vertices, A, B, C, D, on the edge of a circle. That's why cyclic for circle and quadrilateral for four-sided figure. And what I spoke about in the previous lesson is that opposite angles are not equal, but they are supplementary. So opposite angles in a cyclic quad add up to 180. So angle A and angle C add to 180. If I move this around the circle, the numbers will change, but the relationship itself, the opposite angles, will still add up to 180. And that's something that not many people know about circles. It's quite a new idea that most students experience for the first time in grade 11. And we're going to ask lots of questions about that. However, cyclic quads can also look a bit weird. Now, I didn't do this in the last lesson, but look at this. If I move the points like this, look at that sort of weird shape that I get. But notice that the angles are still supplementary. And if I move this here, it almost looks a bit like a butterfly. Those will also still add up to 180. And so I want you to be aware that what the cyclic quad looks like might change over time. And we're going to practice some questions now about that. The other thing I wanted to point out that I mentioned briefly in the last lesson is the exterior angle of a cyclic quad. Actually, I didn't really talk about this too much. So I'll give it a moment. So we've all heard of the exterior angle of a triangle theorem, but not many of us have thought about the exterior angle of a cyclic quad. Now, an exterior angle is like it sounds, it's on the outside, and you could actually have four exterior angles, but let's just play with this for a moment. So here is my cyclic quad, and I'm moving the vertices of the quadrilateral around, and notice how the green angle at the top is changing, and that's also affecting the opposite angle, and how the exterior angle of a cyclic quad always stays equal to the interior opposite. So the two ones I want to connect are that one over there to this one over here. That relationship, we know that the exterior angle of a cyclic quad will always be equal to the interior opposite. Now, the goal for today is not really to do anything more than just use that. We don't have to remember the fancy names for things yet, but I want you to be aware that this fact, or the fancy name for this theorem, exists. And so we're going to try and use these two facts to solve some problems to start today's lesson. Give me a thumbs up if you've understood the basic ideas I just presented. Give me a thumbs down if you feel like you don't really understand the facts I just introduced you to. Okay. So to start today, what we're going to do is we're going to do these four questions over here. And so in these four questions, you have to find unknown values using facts about circles that I've introduced you to. And in question one, in order to answer in the chat, you're going to go 1, A equals something, B equals something, 2, and so on. And actually, I'm not going to do an example because I feel like I've given you the basic idea. All I'm going to say is there are two facts that you need to bear in mind. The one is what happens when you have pairs or we call opposite angles in a cyclic quad. What's their relationship? And what's the relationship between an exterior angle of a cyclic quad and the interior opposite? That's the only ideas I want you to keep in mind. And so see what you can do for questions 1 to 4. I leave it to you guys. And Miss Anya, are there any comments or questions from you?
I'm just keeping an eye on the,
yeah.
I'm keeping my eye on the chat. It's a bit of a mix between thumbs up and thumbs down. So just to reiterate, so the opposite angles in a cyclic quad. So while Sir's drawing, so a cyclic quad is just a fancy word for a four-sided shapes in a circle, where each corner is on the circumference. Yeah. So I'll give it back to you. You can carry on from there.
Perfect. Thanks for letting me know about that. So a cyclic quad is really just a quadrilateral where its 4 vertices or corners are on the circle. Now, the fact that I'm telling you today, I'm not proving it, but I will prove it later, is that opposite angles have a special relationship. They're not equal to each other, but they add up to 180. So if we look at, let's say like this one, and then that one, the opposite angles in a cyclic quad always add up to 180, or what we say is they're supplementary. So that was the one fact that I want you to use. The other fact is if you have an external angle in a cyclic quad, you need to extend one of the sides. So let's say I extend that side. If I change the color here. Let's say I take my cyclic quad and I extend one side. Now I have an angle over here. Now that angle is called an exterior angle. Now that exterior angle has a matching partner, or is the same value as the interior opposite, which is this one up here. So the two angles colored in yellow they have an equal relationship. And I'll explain maybe a bit more in a moment, but essentially those will be equal. If I have another exterior angle, let's say I have this one over here, and I extend that line, then let me use a different highlighter just to point this out. Then this angle over here will be equal to that angle over there, because the exterior angle equals the interior opposite. So I hope that helps a little bit in just using, I'm going to go through the questions in a moment once I see the answers coming in. I just want to give a little bit more time. In fact, I'll do the first one with you. And the rest of you can carry on working. So 1, we would say that 86 plus A must be equal to 180, because these are opposite angles in a cyclic quad. We also know that 105 plus B would be 180. But now I have to work out what A is, and I have to work out what B is. So in order to get to 100 from 86, I need 14, and then I need to go another 80. So I'm going to get 94. And then for B, 105 plus something gives me 180. B is going to be 75. And so I know that these angles would be this. And for today, all we're focusing on is using these facts. At a later stage, we give them special names. But for now, yeah, we're just getting familiar with facts about circles. Students don't spend a lot of time looking at circles. And so you need time to get used to the layout. So what is the relationship between C and angle 101? I think that is an example of an exterior angle and an interior opposite, which what I've said so far, C must be 101. Okay, I'm going to wait a little bit because I know lots of students are still busy. I'm going to actually even stand up.
So David, just to answer your question, David's asking, how can C be 101? So I was going to jump in here. Besides the theorem it's so used, if you go look there in the corner where his cursor is now, a lot of learners would have first gone and write and said, okay, angles on a line. So 180 minus 101 is 79, if I'm not mistaken.
Yeah, that's perfect.
Okay. And then what students would do is say, right, 79 plus C or plus something must give you 180, correct?
Yep.
So, and then eventually you get to 101. But because, David, maths people, we always find short roots in life, always. And there's a theorem that basically, after mathematicians worked, is like, but guys, there's a shorter root. And they found that the opposite exterior angle, that's another way to word it,
Yep.
is equal to the opposite interior angle. Does that answer your question, David?
But it's actually an important point you make, Anya, is that there's actually more than one way to get to the answer. And as long as we're all getting the same answer, it doesn't matter. So you absolutely could have used the fact that angles on a straight line gets you this, and then go together, 79 and C add up to 180. That's perfectly fine. With D, we don't really have the option because we just have 96. And so D must be 84 because together it adds to 180. Okay, let's give a bit more time. I don't see answers for X, Y on C and D yet, so I'm going to give more time for that.
Sir, may I suggest something?
Please go ahead. Yeah.
I want David to do Y for me.
Yeah. Get what? So David, we want to see what Y is, and we want you to pop it in the chat, please. And let me see who else has been answering. So I can, again, we want every single person to be answering. That's really important part of the model. So Kiribona is on fire. Ayabonga is on fire. Tyrese is on fire here. So I want to see you commit. Again, even if you get it wrong, guys, if you commit by putting it in the chat, your brain then, when you see the right answer, it either gets this like, yay, I got it right feeling, and it remembers it, or it goes, oh, I got it wrong. Look, there's the right answer. And that process helps you remember it. So please put your answers in the chat.
Okay, so
yeah.
David, I know a lot of learners are posting the answers in the chat, but David has actually shared his answer. So for Y, he got 64. And I'm pretty sure there's another student or two that also mentioned 64.
Oh, okay.
Can you maybe just give them a bit of an explanation about why they probably thought that was the answer and how to go about that?
Okay. The big thing here is when you're looking at Y, in order to get, there's this 116 sitting up here, and it's kind of drawing our attention, right? But if you think about the main fact from earlier in this lesson, opposite angles in a cyclic quad. Now the cyclic quad, just to point this out, because I know it's very new to you, here is the cyclic quad. Now, where are the opposite angles? Well, the one opposite angle is here and here. That's the one pair that we're very interested in. Now, if I was wanting to know this one down here, this would be 64, because 64 plus 116 is 180, or supplementary. However, if you're interested in Y, which is the thing next door, this thing over here isn't going to be 64. It actually, if you think of angles on a straight line, it has to be 116, because that's what will, if you add 64 and 116, you get 180. But like Ms. Anya was saying, sometimes after a while, you start to notice, I see this relationship. The interior angle of a cyclic quad is always equal to the external opposite. And so it allows you to go there in one step. But the 64, the students would have got confused because of the 64 being next to the Y, but not the actual Y. Now, I'm going to use the same trick for X and 92. If you look at X, 92 is out here, X is in here, X is interior. So this is the opposite, and this is the exterior opposite. It's the opposite on the outside. And so X must be 92. Okay, and then the last one, I think we started this in the last lesson, maybe it looks familiar, but if we look at this one over here, let's first find our quadrilateral. Here is my cyclic quad. What are the opposite angles? The opposite angles are these two. And I shouldn't make it the same. They're not the same. The one's 2C and the other one's C. But basically, you would say 2C plus C is 180. And you can also say D plus 3D is 180. And then you can work out, okay, well, if 3C is 180, then C must be 60. And if 4D equals 180, you can either say 4 times what gives you 180 or divide both sides by 4. And then you get 45. So D would be 45. Okay. So that's the basics of how you would solve problems with a cyclic quad. It doesn't mean you're a cyclic quad ninja, but it gives you like your yellow belt or whatever. Give me a quick indication with your thumbs. Thumbs up if you feel like, okay, look, it's a bit strange, circles with lines and stuff, but this makes sense. A thumbs down if you feel like, okay, no, this is too much. Just so we get a feel. Okay. So what we're going to do now is I'm just going to focus on 2 questions. Okay, so quite a few students are feeling unsure. Okay, yeah. Let's slow down for a second. Quite a few. Okay. The main thing I want you to point out, whenever you're going to do this. Whenever you see a question with cyclic quads, you're first going to ask yourself, where is the cyclic quad? And you're going to highlight it for yourself in your brain. And then I think for a lot of students it will be easier to just work first with the pairs of opposite angles in a cyclic quad, and then work in a second step with angles on a straight line. You do not have to use the exterior angle fact if you're feeling unsure about it. So you could just only use the opposite angles in a cyclic quad add up to 180. Okay, the question from Retabile is, how is 2C and C equal to 180? Let's really focus on this for a second. If I can zoom in, if my thing will actually let me. Here we go. Oh, okay. Let's get rid of the distractions. First of all, do I have a cyclic quad? Here are my 4 points. The 4 points are here, 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 and here. Now, do I have opposite angles in the side? I know it's a weird cyclic quad. It looks like a confused table mountain. But if I go like this, that's a bit big, isn't it? Let's go to marker and let's make that marker. Oh no. Okay, let's go to pen. Then we'll go to red. So if I go to this angle here, what is the opposite angle to this one? It's going to be that one over there. Now they're not equal. We say that D plus 3D they're opposite angles, so they're supplementary. They add up to 180. The same is true of these. And it looks weird because they're hiding here, but this and this, these two, C plus 2C, because they're opposite angles in a cyclic quad, they add up to 180. So that's where it comes from. Okay, now it seems like that helped a little bit. I want to go very slowly now on one question. I know this is a bit harder. If I could just zoom in, if my thing can let me zoom in here. How much can I zoom? I hit the max zoom level here. Maybe if I go Control plus. Nope. Okay. What I'm going to do is I just want to focus on number 5 for a second. But there's a little bit of extra stuff going on in number 5. In number 5, you need to find this angle H down here. But there's a lot of clutter going on here. And so I want to first ask you, what I would do when I see this clutter is go, what other information am I given and what do I know for sure? Now I know that there's a cyclic quad hiding amongst all these lines. So there's a cyclic quad, but there is also, what are these 2 whiskers down here? What do they mean? Can you put it in the chat? What are these 2 things over here? What are these 2? They look like cat's whiskers. What do they mean? Okay, they mean equal, or it's an isosceles triangle, yes. And then I've also got, up here, I've got this angle up here. Now that does something. So I want to see, can you try and get, and again, some students will find this, we've only just, if this is your first lesson today, you definitely will find this difficult. we've already had 4 lessons on circles, and they're all recorded, and we really encourage you to go back. But just do your best. If you were trying to find what H is in number 5, try and do that, and just see where you get. For students who are really on top of the world, see if you can find what M is in number 6. But I just want you to take the time and enjoy this, savor it. Go like, what relationships do I know about? And see if you can get me a value for H in 5. And then if we're struggling, I will give you a few more tips. How are we going to get all the good stuff is sitting up here? How can we get this good stuff down to this part of the world over here? What can we do? I want to see what you can do there. And then the rest of us, if you're feeling comfortable, try and get the answer for M, and then we'll look at the chat. I'll say to you, what's the relationship between that angle, or even, what about if I wanted this angle? Could I get this angle over here? And then maybe once I got the X, I can get the dot down here. So I'll give you some time for that.
So,
yes.
Maybe not for number 5, but I was thinking maybe for one of the examples or questions we're doing tonight, maybe we ask one of the students to explain it to the other students.
That's a nice idea, yes. I think that's a very cool idea. We'll do, when we get a, maybe we can even do that in this round. I like that. Very innovative. So I see some answers coming in for M and some for H. For those who are really feeling very strong at the moment, I'm going to add number 7. But I don't want you to feel intimidated or rushed. I just want you, but I'm just going to add that as an option for those who are feeling on top of things. For number 5, I think most students would probably benefit from just figuring out what this next door angle is. And I'm going to say this is 74 because of angles on a straight line. Then, if I know this is 74, the opposite angle in the cyclic quad is going to be this dot down here. And what is it going to have to be? Well, I can even give it a little, I can even say like, I don't know, maybe I shouldn't call it A, but whatever this thing is, maybe I'll call it X. X plus 74 must equal 180. What does that X need to be? Well, I need 6 to get to 80 and then another 100. So this is going to be 106. And at least now I've got some numbers in my neighborhood. But note how that angle and that angle are exactly the same. And we kind of expected that. Now we go back to lesson 1, I think. And we go, how do we solve for the base angles in isosceles triangle? What are these two going to have to be? Well, they're going to have to be equal. And so we go, well, a whole triangle adds up to 180. So let's go 180 minus 108. And then let's say what's left over. What's left over? So I get 2 to get to 110. I get 72. But those 72 needs to be split equally between the two angles. And so H should be 36 degrees. And that one over there will also be 36. Okay, see if you can use that idea to help you in question 6. And number 7 is a little bit tricky, but I'm not too worried about number 7 because those people are going ahead. For now, number 6 is where I want all the attention.
So,
yes.
I want to check for number 5, H's value. Should it not be 37?
So, okay, if we go, we're happy with 74. So let's just check. 74 gets us, that's perfect.
No, you see where you wrote your equation. Sorry to interrupt. You said 180 minus 108. It should be minus 106.
You're quite right.
That's why.
Thank you so much. 180 minus 106. See, guys, you actually have to, it's really good to always check your work. So now it's 4 to get to 110, so 74. And then we split the 74 into 2 pieces. And if we split 74 into 2 equal pieces, we should get 35, so 37. Thank you so much. Who was that who pointed that out? That was fantastic.
No, I saw a few learners asking. Kevin said, oh, Sarah first said, is it not supposed to be a different value? Kevin also pointed out, and then and then I'll check quickly. So thank you guys. We also make mistakes.
No, but not just that. I love how involved the students are. So the key to this is, one of the wonderful things about being online is we can work very dynamically, and we can sort of interact in a way that we wouldn't be possible in a normal classroom. And so it's actually, sometimes we learn more through these mistakes, but as long as students are being active, it's actually fantastic. Okay, so for M, we're trying to find this angle on this side, but there's a lot going on in the drawing. So it's probably good to take a moment to just think, what are the shapes that make this drawing? And when I first look at this, okay, I see a circle, but my brain is drawn to this triangle over here. So there's that big triangle. Then there's also a triangle sitting over here. And then hidden amongst that all is a, let's get a blue there. There is also a cyclic quad, I think. Let's see. Yes. And so there's quite a few relationships that we need to keep track of. But really, I suppose the first thing I want to do is say, well, the only angle I've got is 31. And I know this is isosceles, so therefore that's 31. Could I work out what D is? So that's quite important. So I must make sure I don't make the same mistake as last time. So if I've got 31 and I've got two of them, together that would give me 62. And now I can work out D because I can go 180 minus 62, which is going to be 120, and then take away two more, 118. So angle D over here is going to be 118. Okay, so now I have a choice. I can either, at least I know it's one of my cyclic quad angles. Most students will probably try and work out what that one is down there. Okay. And that's the opposite angle in the cyclic quad. So what is 118? Oh, did I make it go away? Come back. Here we go. So 118, what goes with 118 to get to 180? What's going to be the opposite angle in the cyclic quad? I get 2 to get to 120. This is going to be 62. And that's going to mean M is 118. Did most students get M is 118?
I'm checking now.
Perfect.
We had a few, who I saw it now, Zianda said M is 118.
Okay.
Suzanne has also said 118.
Yes.
Alini.
Okay. We're going to keep going slowly. I'm not going to go too quick. So I'm just going to, I can feel that we're sort of getting it, but the early stages. So number 7 actually brings something new in. What is new? I want everyone to try and answer this without even answering the question. What is different about number 7 compared to number 5 and 6? I want everyone to look at the drawing. What is different about 7 compared to 5 and 6? And so there's some questions. I'm not getting how we got D. I'll come back to that in a moment. But also look at Miss Anya's tips in the chat as we go. There are 2 quads in the circle. Yes, Nolwazi, you're right. But there's something else I'm looking for. Kiribona, can you're right, but tell us what's in the drawing. What is different about number 7 in the drawing? If you just look at the labels even, and then I'm going to go back to number 6 to explain it in a moment. Okay, number 7 has a center of the circle. So in number 7, there's a center of the circle. There was no center of the circle in question 5 and 6. This is really important because we have different facts or facts that can help us when we have the center of the circle, and we couldn't use those in number 5 and 6. So that's one really important difference. And I want you to pick up on that because knowing what stuff applies when is important. So there's a little bit of confusion about number 6. So I'm going to go back and help you. In number 6, I first want to look at this isosceles triangle up here and notice that these two are base angles in an isosceles triangle. So they have to be equal. So that's 31, that's 31. Now, altogether in my triangle, I have to get to 180. So the two little angles together are 62. And then to get to 180, I have to add 18 and 100. Because 18 gets me to 80, then 100. So this angle is 118. Now, if you know the exterior angle of a cyclic quad theorem, you know that this thing over here and this angle over here are the same. But most students probably would find that a bit confusing. So what I suggest you do is you go, look, what is this angle over here? And that angle over there is not 118. It's the opposite angle in the cyclic quad. Together, they give you 180. And so that angle is going to, in fact, be 62. And now, if that's 62, then angles on a straight line say that this must be 118. I'm just going to finish off number 7, and then we're going to have a break. We're going to have a brain break. So number 7, yeah, question?
Sorry, so before we jump into number 7, can I quickly show the learners something if you don't mind?
Please, go ahead. Go ahead and do it, yeah.
So look at my pretty piece of art. So this is a cyclic quad.
Yeah.
Yes, I have. Okay, so you guys can see that very lovely art. So when you see a cyclic quad and you see that there's, I call it like a tail, right? Where the one side is extended. Okay, that's not very accurate, a bit more like that, right? Okay, think of it as being like flying a kite. You know those cartoons with the kites? So if this is the string of the kite, okay, then this is the top of the kite, okay? So where the angle of the string should match the top of your kite. So that's one way of understanding this theorem. Yeah. But if you're struggling, nothing stops you from working out supplementary angles, other words, angles on a line and then going across. That's fine too. Okay, back to you, sir.
Thanks so much. Okay, it's really important that you try different ways of doing this and find what works for you, because people do it very differently and they see different shapes. And so you must find your style in doing this. So for example, when I looked at this question, I first of all spotted the center of the circle and I knew, okay, bear that in mind. But then also bear in mind the fact that what can I work out straight away? What are my goals here? And my goals are to find what E is and then what F is. Ah, okay, let me put that back on just so that there's no thing. Okay, let me make you a host as well. So participants, just so we don't get any confusion. Okay, change host, all good. Okay, all right, so what I want you to do is we're going back to one of the previous exercises that we did. It's called a pen flip. And I want you to have a pen in your hand and I want you to hold the one side. And the goal is to toss it so that it rotates once in the air. Now, if you're feeling like this is too easy for you, what you can do is you can use your non-dominant hand. So you take it and you toss it and you want it to only spin once and you want to catch it on the same end. So I'll see if I can do this. I think my camera is too manual focused, but see if you can catch it on the same end. And if you can do this, wrong end, see. If you can toss it in the air once and catch it on the right end, then you have achieved in life. Now, if you really want to get to the ninja level, you take your non-dominant hand and see if you can rotate it and toss it in the air and catch it on the same end. Oh, look at that. Years of practice, guys. Oh, that was two rotations. That doesn't count. And just see for a moment if you can, see if you can do that and give yourself a brain break. If you can do it, put a smiley face in the chat. Okay, so if you can, Anu, it says I can't share my screen right now. So can you allow me to share my screen? I think somehow I've made university type exercises. Yeah, guys.
I think I'm the main host now. Let me just see if, well,
maybe make me host again while students are practicing their pen flips.
Try now, sir.
Okay. Yeah, it's a bit easier now. Thank you. No problem. So, guys, what I want you to do is I really want you to practice that because it's actually really good for you. But it's also really fun as well. Well, it's fun to get your brain into a bit of a break mode. Then I have another brain break for you. So I want you to tell me what is, I don't think we've done this before. Maybe we have. What is this equal to? And when you know the answer, you can pop it in the chat. I would love to know what is a hamburger plus a packet of chips times a cool drink equal to?
Oh, sir, do you mind just bringing your camera down a little bit?
Oh,
sorry. There we go.
I am in my enthusiasm. Can you hear that alarm outside my door or not?
A little bit, but it's not the end of the world.
No, I'll just close my door. Yeah. Nothing like an alarm to get in the way. Okay, let's see. All right, so what is a hamburger plus a packet of chips times a cool drink? This actually reminds me of one of our earlier modules, equations and inequalities. But it's not that bad. I'll give you a hint. If you've got 3 milkshakes or cool drinks and they give you 30, each of them must be 10. Now, how can you use that to work out the other ones?
Can I give the kids a tip, sir?
Please do. Please do.
Count carefully how many packets of chips there are. That's all I'm saying.
Count your chips. Yeah. So we know that that would be 10. Answers are coming through. Let's see. If we have 10, now if we know plus a hamburger is 20, and each of the hamburgers have to be 5. That makes sense to me. And then if this is 5, I see what you mean, Mazanya. So part of me wants to go plus 2, but in fact, what have I done now? Oh, I've made it angry, guys. Okay. What should have happened there is each of the packet of chips, there we go. Each of the packet of chips is going to be 1 each. So 5, 1, 1, 1, 1, which means the final answer will be 5 plus 1 times, what is that? It was 10. And so the final answer is going to be 15. Okay. Well done. Well done. Okay. So what I'm going to do now is I am going to go back to what we were doing, which was this one over here. Let's get back into, and that was, I think, from a previous lesson. And this is something from, I'm not going to do that now. Okay. Let's finish with one more new idea for today. So let me make this a bit bigger. And then we'll follow on in the next lesson about this fact. Okay, so we spent most of today thinking about cyclic quads, right? These things that we get when we have 4 vertices and we connect them. It turns out that there are relationships between these angles. That's what we're doing today. But there's one type of cyclic quad that I haven't really spoken about, which is the butterfly shape. And so when you get the butterfly shape, it is a little bit different. And so I want to have a closer look at the butterfly shape. We call these angles in the same segment, which I'll explain in a moment. So right at the very beginning of this series, we spoke about the word segment. So if I take a chord, now I know they're using lots of fancy words, a line from one side of the circumference or from one point on the circumference to another is called a chord, and it divides up a circle into what's called the major segment and the minor segment. Okay, it's not too important right now, but we've done that vocab before. Now, if you have, we call this situation where if you use this chord and or you can use the arc and you draw that angle over there, this thing over here is called an angle at the circumference. But if you use the same chord or same arc and you draw an angle like that, those two angles are called angles in the same segment because they literally are in the same segment, which is over here. It's that part. I know this is looking a bit like a scary monster or an unhappy octopus or something, but these are two angles in the same segment, and these two angles are at the circumference. Now, I just want to take this idea and play with it a little bit. Now, the other thing is notice how you have 4 points. So if I take my idea like this, these 4 points are clearly forming a cyclic quadrilateral. But it has they often call this the butterfly theorem or the butterfly fact. Now, what do you notice about the wings of the butterfly? Okay. These angles, the angles are the same. And in fact, the angles down here would also be the same. The angles at the top of the butterfly wings will be the same, and the angles at the bottom. And so this is the last new idea I want to introduce today. And this is called angles in the same segment. And the angles are equal, yes. But, oh, watch this. Okay, look at this. Notice how when I move these around, those two angles in the butterfly stay equal. And all I'm really doing is if I move the blue dots, can you see how the red, actually, can you see how the red bit between the blue dots, it's highlighted? That's called an arc. If I drew the line between the two blue dots, it's called a chord. Sometimes they call it angles in the same segment. Sometimes they call it angles on the same arc. It's the same basic idea. The main thing is I want you to just be aware of it. Now, how do we use this in a question? Well, let's do question number 1 together. Using this butterfly idea, if we think about the same arc or the same, this thing over here would be the base of the thing that I'm building. And if you think about that angle at the circumference, and I also get, what is the value of A going to be using the idea that I just showed you? Put it in the chat. What does A have to be? I want to see what everyone says. And what does, maybe you know what B is.
And then, so while they're posting a chat, I know you refer to it as the butterfly method, but I know a lot of schools also refer to it that when the teacher will say, well, can you look for the bow tie?
Or the bow tie.
So if you can't see the butterfly, think of a bow tie. That's also an easy way. So the top corners are equal and then the bottom corners are equal. Right, back to you, sir.
Perfect. The other thing while you're getting this, guys, is when you think of the bow tie or the butterfly method, it always is a common arc or common chord that helps. We say that this arc subtends the angles. And so just to show you that if we thought of that arc, it can build an angle of B at the circumference, and it can also build an angle over here. And so these two over here are also related. So what is A and what is B? Okay, so you're quite right. A is going to be 27 degrees because these two are partners in the bow tie. And B is going to be 30 degrees because these two are partners in the bow tie. Notice how the top and the bottom of the bow tie have different values. but the partners have the same value. Okay, so this is also, this falls, when I think about circle geometry, I have three buckets. I have the center of the circle bucket, okay? I have the cyclic quad buckets. Oh, how do I do this? The cyclic quad buckets. And then I also have the tangent bucket. And those three ideas are kind of the main facts in circles or about them. Okay, can you please do for me number 2? What is angle D going to be equal to, and what is angle C going to be equal to? I'd like you to put that in the chat. And I want to see what you guys can do. So first ask yourself, where is the butterfly? And I think the butterfly, well, that's too thick. Let's change the colors. So draw. Let's make it thinner. So I think the butterfly is there. And this one is the matching partner in the bow tie of that one. Yes. So C is 20 and D is 45 is what most students seem to be saying. And you're quite correct. And we can even, you know, this relationship does hold up. Now, I really want you to take a moment and realize there is no mention of the center of a circle in this question. There's no center. All you have are the 4 vertices of a cyclic quad. And between those vertices, you have this sort of bow tie type shape. And really what's happening is just this. Oh, no, wait. Sorry, I'm not drawing properly. But just bear that in mind. Okay, last 2 questions for the day. And then we'll wrap up. Can you do number 3 and then number 4? But notice how I give you different information. But remember, you now have also triangles that are involved, and you have cyclic quads. So remember, in number 3, you have a normal cyclic quad with everything that you know about cyclic quads. And then you also have your butterfly shape. And how can you bring those 2 worlds together? And you need to find me C, D, and E. And then for question 4, you need to find me F, G, and H. It's almost like you have to decide. It's almost like a treasure hunt. What would I go hunting for first? I got it because, you know, like it's a bit overwhelming otherwise. So where's the treasure that's hiding that maybe I can help? There's no center of the circle. Oh, can't I add? Let's see. Do I have any other information? Well, I think I would probably go after D first. I think getting angle D might be helpful because I think I know a way to get to D, and then maybe I can use that to help me. It looks to me a lot like the butterfly actually, and like this one over here is matching this one over here. And so I can start by saying D is 41 degrees. Now, if I know that's 41, what else can I work out? Or what other parts of the butterfly are maybe, oh, I just thought of something. Isn't there another butterfly? So what part of the butterfly is E related to? I think E is related to 30. Indeed it is. So these are actually matching things over here. These are the, can you see them in the butterfly? And so E is 30. Maybe I should use a different color. If you look at this butterfly, you can see the 30s are matching partners. And suddenly I see it, the 58s are matching partners too. So C is going to be 58 degrees because that and that are matching partners. D, E, C, and I think that is it. D, E, C. Anya, are students generally getting those answers for D,
Yeah,
E, and C?
I think, yeah, they're generally on it. They're getting it quite quickly. I think also if you look for the butterfly, match the top part of the wings with the bottom, or match the top part. Once you get your answer, then you match the bottom parts. Or the way I remember it, I was at school, I remember it as a bow tie. So I would just turn the bow tie, so how I would wear it. So in this case, I pull it to the side. Then, okay, the top ones are equal and the bottom ones are equal.
Yeah. So I think focus on one part of the bow tie at a time. And then once you've gobbled up all that useful information, because there are actually 2 bow ties involved here. Okay, let's go to, we're almost done for tonight. So let's just finish off with 4. So in this one, it looks to me, as my brain is starting to get more used to this picture, this one and this one are clearly related to each other. So are this one and this one. Wait, color, draw. So are this one and this one. But we don't have enough information to help G and H. We do have enough information to get F, so F will be 40. And then we go, oh, but this is a triangle. So we go, well, if I go 40 plus 85, I've already got 125, which means that in order to get to 180 in total, I would just go 180 minus 25, sorry, minus 125. And so now 55, I'm pretty confident G is 55. And then because G and H are matched, we know H is 55. I don't see a 49. Am I making a mistake here? Let's have a look.
No, you're right. But I think also the keyboard, the 9 is supposed next to the 0. So I think it's just a typo.
Okay.
So.
Totally. Okay, guys, I don't want to do too much in any one day, and I know I'm really pushing you already. So I just want to sum up the main ideas from today. The main ideas from today were that if I have a cyclic quad, there are pairs of opposite angles that have a relationship. So this one and that one. Then the other big idea that I spoke about was that the exterior angle of a cyclic quad exists and that they also have a relationship with the interior opposites. And then the last bit of new information was this idea of if I've got 2 points, well, actually, if I've got 4 points, I get this butterfly type shape, which is a cyclic quad. And there are pairs of matching things, or let me get pairs of matching angles, sorry, not things, that are sitting in this, that is a bit thick, isn't it? There are pairs of matching angles inside the butterfly or the bow tie. Okay, so what I want to do, guys, is that I've really pushed you to the max today, but I'd like to get a sense of how you experienced this lesson. So Anya, if you could put that poll out about, if it exists, about how they found the lesson today on a scale of 1 to 4. And then I just want to say really well done. Like this is a bit like strength training. You build up a muscle every lesson, and then at some point we'll bring all the muscle exercises together in one exercise. But I really want to say well done, because it takes a lot of visual processing to do this. I'm also going to say for those students who would like to leave, once you've done the survey, you're welcome to leave, but we will stay on the line for a moment or two just to answer some questions. And so we'll go from there. But really well done for today, and I look forward to seeing you on Wednesday. Okay, any questions?